Let's look at this bracket here to see how strong it is. With SolidWorks Simulation, we can easily run a test to see if it'll hold up to the loading. In this example, it needs to hold 3,500 pounds safely. Just like every simulation, it's the same few steps: material, fixtures, loads, mesh, results. Here, we see it will in fact hold up because the factor of safety tells us it can hold well over the expected use case. Now, this is a common use case with solid elements. Elements are when we break down the geometry into small pieces. This is the process of meshing. This is a solid mesh. Now, meshing in SolidWorks Simulation is really the unsung hero behind the scenes, responsible for making simulation such an easy tool, ensuring accuracy with maximum efficiency. So let's take a deep dive on that. The bracket used solid elements. These can be used for all geometry, but they're most efficient when applied to chunky solids like the bracket. The other elements are shell elements, which are best for thin geometry like surfaces and sheet metal, or beam elements, perfect for weldments. This joist hanger here was created using sheet metal features, so it's automatically meshed with shell elements. It's thin geometry, so it meshes using 2D elements, but the thickness, that third dimension, is taken into account behind the scenes to ensure accuracy while maximizing efficiency. Here's the same shape, but this time it's an imported surface. This is where we give it a thickness, so simulation can get an accurate answer instantly. Moving on from thin shapes to shapes with constant cross sections, like this C channel here. Meshing with solids will technically work, but it's not going to be accurate or efficient. Here's the problem. We need at least 2 elements across the thickness. And here we only have 1. It'll take too long to mesh and solve if we increase the resolution where we have the 2 elements across the thickness. That's where beam elements come in handy. You can change it by right-clicking on the geometry at the top of the simulation tree and define the element type. Not solids, not shells, but this time beams. Instantly, we get it meshed because the beam elements are specifically designed for geometry like this. And a few more things to complete the setup: material, loads, and fixtures, and instantly we get an accurate result. Here's an I-beam, another example, perfect for beam elements. But this time it was created using weldments, so automatically simulation meshes it using beam elements with no additional input. That's the power of the tight integration between CAD and analysis with SolidWorks. Seamless, efficient, and accurate, guiding you confidently in your design decisions.